Alright, new video, new sweater. Maybe I'll get one new sweater for every video series I do, and one day I will have 100 sweaters. But for now, we're just going to talk about data types and pointers in C++. So to formally cover data types, we've talked about data types pretty much this entire course, but now's the formal definition. We're familiar with our int or integer, and this is going to take up 4 bytes. Long ago was 2 bytes, but more commonly it's going to be 4 bytes now. We have these floats and doubles, and they represent fractional numbers. Now double is going to take up twice as much space. So a float will take up 4 bytes and a double will take 8 bytes. We have our characters, so something like a $sign or the letter B. That's only going to take up 1 byte. And then we have our booleans or bool, so that's going to be our true-false values. And again, that's only going to take up 1 byte. So booleans are a little bit tricky, but how we would define that in the code, we would have some bool, call it variable1, and that would be equal to true. Now the reason that we're talking about these bytes here is because recall from the array video, we had this size of line of code, and this did not give us the number of elements in the array, it simply gave us the size of the array in bytes, and we had to use a little trick to actually get the number of elements. So now if we go back to that array code, and inside this array code, we added one additional line of code. So line 19, we're just going to output the size of the array is, and then we use this size of command, and then we just say bytes. So if we run this code, and you can see here the size of the array is 20 bytes. Now, where is this coming from? Well, notice in the code, we have this ages array, which is just going to be the current year minus the birth year. So we're going to have 5 values, and it's going to be all integers. And we know from right here, an integer is going to take up 4 bytes. So we have 4 bytes 5 different times in that array. So that's why we get the size of outputting 20. Now because booleans are tricky, we're going to give them a little bit of attention. And to use booleans, maybe sometimes you want to use this comparison operator. And that can be how you can get your true or false result. So if we look at some example code, let's say we have some integer, call it var1 to represent variable 1. Let's say it's equal to some number. And then this is where it gets a little bit tricky because we're going to have this cout, and we're going to have this comparison operator, these two equal signs right here. And it's going to be comparing variable 1 up here to 63. And because the comparison would not be correct, this would output a 0 to the terminal, and that would represent a false. If we changed variable 1 to equal 63, and we ran this, then you would get a 1, and that would represent a true. Now, taking this even further, because we're talking about bytes, and we know that all of these data types take up some memory, that introduces us into pointers. So it's safe to assume that all of our variables get sent to their respective location or address in the memory. So kind of think of this like a mailman first. They find your address and then they deliver the mail. Or I guess if you put the little flag up on your mailbox, they might take the mail as well. But it's this address that we're interested in. And we know from our code that we can access the variable at that address, but we can also access that address directly. So we're going to introduce something called dereferencing. So to dereference from that address in the memory, we can commonly use what we've pretty much been using in all these videos. So we just call that variable 1. But to be more maybe accurate or politically correct, we would use an asterisk, and then we would have these parentheses, and then we'd have an ampersand, and then we'd have that variable 1. But to actually get the address, we just use this ampersand and then variable 1. Now maybe you're asking, why do I even need to know the address? Why is it not good enough just to know the variable? And for what we've done so far, this is a valid question. But manipulating the address can be significantly more optimal or better than changing the data that's associated with that address. Now again, for the stuff we've been looking at, maybe not so important, but when you're looking at code that is, larger than 1,000 lines of code, this might be the better option. And of course, we can't cover 1,000 lines of code in a few minutes of a video. But if the videos in this series do well and I don't get any copyright claims, maybe we'll start to look into some pretty large projects that involve writing a decent amount of code. But moving on, this is where we're going to talk about how we can actually use these pointers. So a pointer is a variable, and that variable is going to store the memory address. So let's say we have some variable 2 that we define as 5. We can then use this int with this asterisk right here, and then we define pointer2 associated to variable 2, and we're just going to say that that is equal to the memory address of variable 2. So we have this ampersand. Now we need to match the data type for the pointer and the variable that it's pointing to. So notice here we have int and int, so both are integers. And what we can say from this is that pointer2 holds variable 2's memory address. But if we put that asterisk right here, so we have asterisk pointer2 instead of int asterisk, well, then this will actually output the variable that is at that address it's holding. And this might seem a little bit circular, so let's go into Visual Studio. So we can see here in these lines of code that are commented out, we're going to have some variable 1, it's an integer, we're going to call it 1. And then we're going to output 3 things. We're going to output variable 1, which is similar to what we've been doing. Then we're going to output the memory address of variable 1. And then we're going to have our formal dereferencing in line 8. So if we run this, you can see we outputted our variable, the memory address of our variable, and then that variable again. So now if we swap the commented blocks of code, you can see here that we have variable 2 as 5. We have a pointer defined now. So that's just going to be the memory address of variable 2. And again, we're going to output variable 2, the memory address of variable 2. Then we're going to output pointer2, which is the memory address of variable 2. And then we're going to dereference from that pointer, so it's just going to print out the value that is associated to that address. Now if we run this, so if we go back to the whiteboard and we look at another element of the code from the arrays video, we used this min element thing. And what this min element line of code did is it returns an iterator. Now an iterator is not a pointer, but it can be similar to a pointer. So you can kind of think of this as an iterator points to a value rather than returning the value in a data structure. And in this case, our data structure was our array. So that min element line of code is going to point us to the lowest value in that array. And then we use that asterisk to dereference from that. And that gives us our value. So if we just look at that line of code again, you can see that this is why this asterisk is in here. And if we actually hover over min element, you can see that it returns an iterator that references the first instance of the smallest value. And pointers aren't the most fun thing to learn, but they are a crucial component of writing any kind of code. But in the next video, we're going to talk about something that's very important to C++, and that's going to be classes and objects. And we'll see in the next video. If you learned anything, found anything useful, please like, comment, share, subscribe.